this. So now if you have multiple double bonds, so it's going to become diene, or you have to mention the position of both double bonds. Okay, and the position is going to be counted from the side which gives the smaller number. Here you had alcohols. In alcohols, again, it's the same rule that the name would end with all. Okay, the suffix would be all. This it would start with the number of carbon atoms. An and En would indicate whether it's saturated or unsaturated. Okay. So this one over here was butanediol. Okay, it's on the second. OH is on the second one. This one over here is uh, it's butanol, but it's En instead of An. And you mentioned the position of the OH and the double bond. So we did multiple functional groups. Then we started talking about carbonyl groups. In carbonyl groups, you had uh, one second. In carbonyl groups, you had C double bond O and only C double bond O. Okay. So remember, carboxylic acids are not carbonyl. Esters are not carbonyl. Amides, they also have C double bond O. They are not carbonyl. Only C double bond O is carbonyl. So you had aldehydes and ketones. So aldehydes, the naming was easy, that the name would end with al. So it's propanol. Okay. An indicates whether it's saturated or unsaturated. Uh, An becomes En if there's a double bond as well. So the name ends with al, and you don't have to really mention the position of the aldehyde group because it's always at the end. Aldehyde is C double bond O is always at the end of the chain. And you had, this one was a dial, which means a dialdehyde. Both sides, you had aldehyde groups. Even if you hadn't mentioned the position, you would still know that it's the only place where the C double bond O could be put in an aldehyde is if it's at the end and at the beginning. So anyways, the next one that we're going to talk about is going to be a ketone. Now, how do you name a ketone? And what's a ketone? Ketone kanda you had C double bond O somewhere in the middle. So let's focus on ketones. And the suffix is, it's pretty obvious what the suffix is. The name starts with the number of uh, uh, you have the prefix, which is always the number of carbon atoms, and you have an and en in the middle, okay, whether it's saturated or unsaturated. This and the name would end with on. And this is where you're going to mention the position of where the ketone is. So the name ends with on. You're going to mention where the ketone group is attached. So for example, we'll do the first one. I have 4 carbon atoms, and this one is a ketone, so there's a double bond O over here. This one would have 2 hydrogens, this one would have 3 hydrogens, and there would be 3 hydrogens over here as well. The name of this molecule would be, it is saturated, so it's An and ONE. So it's butanone. Uh, this ketone group is at position number 2, so it's butanone. Okay, and you have to, uh, you can put them together, so it's butanone. Is this clear? Rida, is this clear? Bazga clear? Ibrar?
Yes, sir.
So this one is butanone. Similarly, we can have another molecule, and this molecule has 3 hydrogens over here. Uh, let's say there's a double bond over here, 2 hydrogens over here. There's going to be a hydrogen over here, and 2 hydrogens on this carbon atom. The name of this molecule would be, it's pent, 5 carbon atoms in a line, and it would be En because it's unsaturated, and on at the end. Now the on is at position number 2, so it's going to be at position number 2, and the En would be at position number 4. So it's going to be pent 4 en 2 on. Okay, is this clear to everyone? Ibrar,
Yes,
Abba
sir.
is okay.
Yeah.
So these are
Yes,
aldehydes.
sir.
So these are aldehydes and ketones. You can remember, it's just sterile bond O. At the end, that's an aldehyde. If it's in the middle, it's a ketone. The
Sir,
next,
I have a question. जी.
yes.
Sir, I was saying कि for ketones, मतलब, is this oxygen supposed to be on the second carbon always?
नहीं आपका ये question है कि why isn't it 4?
नहीं, I'm actually saying कि मतलब, will this carbon double bond
अच्छा नहीं,
oxygen
it's
always remain?
नहीं, the rule is it has to be somewhere in the middle. ठीक
All
है?
right.
I mean, like over here in this molecule, these are the only two options. ठीक है?
Oh, अच्छा.
In this molecule, it's the middle ones, any one of the three. So, but it could have been over here as well on this one.
All right.
अच्छा, then,
Sir, could we write it the other way around?
okay, this one is 2 and this one is 4.
Yes.
No, you can't actually. I'm going to come to that. Okay, we haven't talked a lot about position. Okay, how do you count the
Okay.
position? Okay, so we're going to come to that. Actually, the other thing is, okay, what's left? You have, I mean, naming halogenoalkanes. There's a thing called halogenoalkanes. So remember, halogenoalkanes are simply an alkane with one halogen or more than one halogen. So, for example, this is okay. This is a halogenoalkane. This is one carbon atom. So you don't change it. You still call it an alkane. It's still methane. Okay. Remember, the halogen is always treated as a branch. I mean, it doesn't become part of the name. Okay. So it's treated as a branch, as a Cl branch. So you're going to call this chloromethane, and you're going to tell the position that it's at position number 1. Okay, that's it. Uh, so this is how I'm going to come back to halogenoalkanes later on as well. So this is how you mention halogenoalkanes as branches. Okay, you still call it an alkane, or you don't change the molecule name. It's always treated as a branch. The next one is carboxylic acids. Now, carboxylic acids are uh, one second. So what do carboxylic acids? Carboxylic acids are your C double bond O and OH. Okay, that's the functional group of a carboxylic acid, which is written as COOH or CO2H. And the naming would be again this one, like an aldehyde. This one would always be at the end of the chain, or you can call it the start of the chain. It's always position 1. Okay, whenever you see a carboxylic acid, it's always position 1. So whenever you see a carboxylic acid, let's say there's a double bond and there's I mean this is 2 hydrogens. This would have 1 hydrogen, and there would be 2 hydrogens over here. So this one is bute. En becomes En, and it's going to become oic acid. Usually, just like aldehydes, you never mention carboxylic acid. I mean, you can mention it, but it's pointless. Okay. So just like an aldehyde, there's no need to actually mention where the carboxylic acid is, because it's always going to be at the end, and all your countings are going to start from this one. So if it's bute, the double bond is at position number 3, because you're going to start your counting from this side, 1, 2, and this would be 3. So it's going to be so it's going to be bute 3 in and oic acid, and you can put them together. ठीक है, clear है? Abba, is this clear? Rida?
Yes,
Bhaskar?
Yes.
sir, over here, do we follow वो वाला rule जहाँ पे we actually name them alphabetically, as you said.
Alphabetically, like how? Remember, we haven't started
Uh,
talking about branches yet. Okay?
yes,
So, I mean, we haven't. Did we study somewhere where it was? I mean, anything? I
I
mean,
guess. Yeah.
right now we're just studying functional groups, the different homologous cities,
Mm,
and
exactly.
as our alphabetical naming, etc., branches we haven't studied yet. Okay? So right now, what we're only studying is that if you have a straight chain simple molecule, how do you name it? Okay? That's what we are studying. So this is carboxylic acid, and I'm going to do a few more just very quickly now. You have a thing called amine. Okay, so you have an amine. I always forget whether there's a double M or there's a single M in an amine. Just one second. I think it's a single M. Auntie gets it's single M. So you have amines. Amines are that you have a carbon chain, and there would be NH2 attached. Now, amines are really not in your syllabus at the moment, as such. I mean, they're just there as a product, not as a homologous series. So, so the naming is. I'm just going to quickly do amines. This would be a carbon chain, and there's two carbon atoms, so it's eth. But the carbon chain is treated as a branch. It's going to be called ethylamine. And similarly, you're going to have propylamine. Okay, so if you have three carbon atoms or four carbon atoms, and there's an NH2, so this would be butylamine because it's four carbon atoms. So this is how amines are named. Okay, I'm not going to go into more details about amines. And the last one is a nitrile. Okay, again, this is also not very important. It just appears one or two places where the product is a nitrile. A nitrile is something where you have a carbon chain and the CN group is attached. CN has a triple bond. CNN have a triple bond. So this is known as a nitrile. So if you have three carbon atoms and there's a CN and this one has two H and this is three H's, so it's going to be called propane nitrile. Okay, that's how you go. If it had two carbon atoms, it would be called ethane nitrile. So that's how nitriles are named. Okay, anyways, the last two are not very important. Now we're going to move towards a bit more slightly more complicated. I said we're going to move towards just one second. Need this is too small.
Sir, can there be double bonds in nitriles that would
हाँ तो
result
वो
in an ene?
तो A and E would change into E N. ठीक है, just the same way.
Okay.
ठीक है, but I'm not going to go. I'm not going into details about nitriles and amines because I mean they're not even in your course. ठीक है, they just appear. एक तो A2 के अंदर है and they just appear one or twice in some reactions. अच्छा, anyways, the next thing is what happens when you have branches and when you have multiple functional groups. ठीक है, now so far we had just studied one functional group in a molecule. So what happens if a molecule is a carboxylic acid? It's also an alcohol, and it also has branches and side chains. Okay, so let's think of a molecule, and it has carboxylic acid. It has so let's keep it simple it has an OH. I said it has CH2 and CH3 And let's say there's a double bond as well. And I'm going to add there's going to be one hydrogen over here. This is complete, one hydrogen over here. And let's say let's add a Cl as well. You get two hydrogens. So I'm going to now how do you name this? What would you call it? Would you call it an alcohol? Would you call it a carboxylic acid? Would you call it an alkene? So there's some rules to when dealing with more complex structures. Okay, and remember the rules are not usually sufficient; they fail very quickly. So I'm going to open the IUPAC nomenclature, okay, which is which is very detailed, and we're just going to where's the Wikipedia page? Just one second. So the first thing is there's a table given over here, and we're going to list. One second. I said this one. Now, hopefully, you can see the table. The first thing is that all functional groups are not exactly the same. Okay, I'm going to keep it on the side. All functional groups are not exactly the same, but you're going to call this molecule a name. Okay, and the first thing is suffix. Would you call it an alcohol? Would you call it a carboxylic acid? What would you call it? I mean, what would be the suffix for this molecule? So how do you determine? You can determine the starting name. We're going to look at the starting name later. There's a thing called precedence of functional groups. Some functional groups are more important than other functional groups. I mean, it's just somebody just made it arbitrarily. Uh, they're not actually important. It's just that just for naming, some functional groups are given more importance. So precedence of functional groups. The number one thing, carboxylic acid is right at the top. Okay. So that means if you look at this molecule, it's an alcohol, it's also a carboxylic acid, but you're going to call it a carboxylic acid. Okay, that's number one. I said, but I'm going to write all the other precedences as well. Right after carboxylic acid, you usually have aldehyde and ketones. If you look over here, uh, uh, we're not dealing with all of them. You have nitriles, aldehydes, and ketones. Okay, we're not even going into details about naming nitriles, uh, but I'm just going to add nitriles anyways. Okay, at number 3 you have aldehydes, and number 4 it's ketones. Okay, so the importance is decreasing. I said, where do alcohols come in? Um, Forget all of these. These are not. I mean, this is alcohols. Okay, it's much lower. So at number 5, I'm going to put alcohols. Okay, alcohols, and after alcohols, right at the bottom, the least important are amines. Okay, and that pretty much uh, where's the so that's what you should know. Okay, forget all the other details. I mean, is the first part clear? Okay, you're going to name the molecule based on the most important functional group. Is this clear? Ibrahim, is this clear? Abba, is this clear? Minail, is this clear?
Yes, sir.
Baza, clear?
Yes,
Yes.
sir.
So, I mean, this molecule over here has carboxylic acid. So you're going to call it a carboxylic acid. And I said, then how would you number the groups? I mean, which side would you start counting from? The second thing is the most important group must be given the smallest number. Okay, that's the second rule. So so this not only determines the suffix, but the other point is that the most important so the most I mean this was what I was talking about, TK, that when you're counting, from which side would you start counting, TK? So you're not going to look at all the other groups. You're not even going to give them any importance, TK. You're going to give the importance to the most important functional group. So most important functional group gets the smallest number. Gets the smallest number. Rida, is this clear? Hiba, is this clear? Acha, so the other I mean the first part is done. Now what's the format? How would you start calling it? How would you start naming it? One thing is molecules are going to be named as position, branch, and then your main chain. Okay, so there are three parts to the name. You'll have your position, you'll have your branch, and then your main chain. Okay, so it's going to be named in three parts. I'm going to start with the main chain. Main chain is going to be your main molecule. Okay, and branches are the things that come out of that main molecule. So the main chain is, I said the main chain has many rules. Okay, we can't even remember all the rules. Okay, I mean the IPAC nomenclature is pretty complicated. In simple words, it's the longest possible chain. Okay, which should contain the highest precedence group. I mean that's the first. I mean that's very important. It should actually. I mean, which contains the highest precedence group. Okay, that should be in the main chain, and it should also have the maximum number of groups attached. And double bonds. Okay, I mean most of the things in the molecule that determine the properties of the molecule, they should probably be in the main chain. Okay, so I can refer to the nomenclature. Just one second, if I can. I mean, this one is kind of more complicated. I've just simplified everything. Okay. I've summed it up that it should be I mean, the rules are a lot more. Okay. But I've just summed it up that it should be the longest possible chain, which contains the highest precedence group and maximum number of groups and double bonds. Okay. So most of the things must be in the main chain. So if you go back and have a look at the molecule, okay, I'm going to figure out what the main chain is. There are two possible scenarios. First one is this one, that 5 carbon atoms in a straight line. That's your main chain. Now that's a very good option for a main chain because it has I mean your highest precedence group is part of the main chain. The double bond is part of the main chain. The OH is also attached to the main chain. The Cl is also attached to the main chain. Plus there's a carbon branch that's coming out of it. So plenty of things attached on the main chain. So this is a pretty good candidate. The other option is, I mean, 5 carbon atoms, right? The other option is this one. I mean, it also has 5 carbon atoms. But should I take it as a main chain? What's wrong with this option? Anyone, any idea? Bhaskar? Should I take this as the main chain? Ibrar? Maybe Abba?
Sir, no. No, sir.
What's the reason? It has the highest precedence group. Carboxylic acid हमने decide किया था ना, that was the highest. But it doesn't have the maximum number of groups attached to it. I mean, the OH is not attached to the main chain.
Exactly. Exactly.
Even the Cl is not attached to the main chain. So it's not a good option, TK, to select this one. So I'm going to stick
Yes.
to the previous one. TK, clear है सारों को? Abba, is this clear? Rida, Hiba?
Yes, sir.
Rida?
Yes.
Achha, so I've selected the main chain. This is the main chain. How many carbon atoms does it have? It has 5 carbon atoms. So start naming the main chain in the same way. It has 5 carbon atoms. It's going to be pent. It's going to be, I mean, not pent. It's going to be pent. I mean, let's call it pentanoic acid quickly. Okay? It's going to be named after the highest precedence group, which was a carboxylic acid. So I'm going to call it pentanoic acid. And where would I count it? Where would I do all the counting? The highest precedence group should be the.
Sir, won't it be pentenoic?
नहीं उस पे आता हूँ मैं. अभी तो मैंने just I mean, I just quickly call it pentanoic acid. This is we're going to
Sorry.
start counting things. Okay. So the first thing is, okay, the main chain is not pentanoic acid as Abrar said. It's ene. It should be ene. Okay, that's the first thing. What's the position of the ene? Like you're counting.
2.
2.
Okay, so it's going to be 2. You're going to count from the carboxylic acid side. So this one is going to be 2. Acha, what about what else? What else is part of the main chain? Okay, the other things are all branches. So it's pentenoic acid, right? So this is the main chain. We're done with the main chain. Now the rest of the things are going to be your branches. Okay, so that's now you're going to mention position in the branch. So all of them, the OH is a branch, the Cl is a branch. I mean, there's this branch over here. So 3 branches. So you're going to start uh, writing all the branches in front of the main chain. Now, one thing about branches is if something becomes a branch, remember this thing that we have to add this. Alcohols are going to be called hydroxy groups. Okay, if they're branches. Amines would be called amino groups, which is why you call which is why you have the word amino acid. Okay, so remember this thing. As a ketones and aldehydes, they actually never become branches. They always remain. Even nitriles, they always remain suffixes. Okay, so they're never treated as branches. I'm going to talk about them later. But remember, okay, if alcohol is a branch, then it's going to be called hydroxy. Okay, so OH over here would be called hydroxy. Cl would be called chloro. And carbon branches are called, this is 2 carbon atoms, so it's eth. They would always be called ethyl, alkyl branches. So you have hydroxy, chloro, and ethyl. And you have to position them. What's the position? You're going to count from this side. Everything would be, I mean, this is the most important group, should be given the smallest number. So it's 1, 2, 3. So ethyl is at position number 3. Hydroxy is at position number 4. And chloro is right at the end. It's at position number 5. So you have these 3 branches, and they are going to be mentioned alphabetically. Okay, they're going to be written down alphabetically. So the first one would be the chloro. So the first one, so it's going to be 5 chloro. The second one after C comes E, so it's going to be 3 ethyl. And then you have the last one would be 4 hydroxy. So it's going to be 4 hydroxy, and it would be pent-2-ene-oic acid. And you can put all of them together. Okay. Is this clear, Bazga, Ibrar? Is this clear?
Clear.
Minail, clear?
जी
Just one second. Acha, so that's how you're going to name these molecules. So I'm just going to go over this once more. Okay. So the first thing that you have to do is remember a molecule is going to be named by its position, branch, and its main chain. Main chain is what is the main chain? It's the longest chain which has the highest precedence group and should also contain the maximum number of groups and double bonds. And the main chain would be named after the highest precedence group. So if there's a carboxylic acid, you're going to call it a carboxylic acid. So 5 carbon atoms, it's pentanoic acid, but since it was unsaturated, so you change the AN to EN and you put the position over there. All the counting should be done to give the smaller number to this group. The other thing is that this one is going to be all the rest of the groups that are attached, they become branches.
There's a case that we have equal functional groups on 2 chains that we can consider as our main chains. What will we do then? Do we consider the
Hey,
number of
that's
carbon atoms?
then simply I told you that the IUPAC nomenclature fails pretty quickly. Okay, I mean,
Oh
it's
yeah,
not.
okay.
Okay, I mean, if the complexity increases beyond a certain point, the nomenclature doesn't really help. Okay, which is why you have generic names for different things. Okay, you start naming them after scientists and stuff. Okay, so the systematic naming only works up to a certain complexity. So I'm going to do another molecule. Okay, I said I'm going to add a few things over here that these things, well, the first four. Okay, they always remain suffixes, which means, I mean, they're always suffix. I mean, main chain suffixes. Okay, one second. They're always main chain suffix. Suffix means they're always going to be at the end of the chain. Okay, like pentanoic acid. It never becomes a branch. Okay, they always remain at the end. So what would happen? But on the other hand, alcohol can be a suffix if it's the most important group. Uh, for example, let's do another example. Okay, you have an alcohol and an amino acid, and a not an amino acid, an amine. Let's say I have this molecule, and there's OH, and there is double bond, and there is NH2 attached. Okay, so this is the molecule. There would be two hydrogens over here, and there would be two hydrogens over here. Okay, so it's a simple molecule. Which group has the highest precedence? TK, if you look at the table that I've drawn, according to the table, the alcohol, I mean, you have just two groups, alcohol and amino acids. TK, so alcohol takes precedence. So alcohol has the highest precedence. This would be your main chain since you only have one chain. So I mean, there's no point in having or arguing about the main chain. You just have one chain. So this would be propanol. TK, you're going to this is your main chain. It would be a propanol. Let me sort of I say it would be propanol. The OH would be at position number one. All the counting must be done to give the smaller number to this OH group. So it's always position number one. So it's going to be propan-1-ol. And since there's a double bond, so it's going to be En instead of An. And the double bond position would be number two. Okay, so if this is one, then this would be two, and this would be three. And you have one branch, which is amine. So you have one branch, which is your amine branch. So what happens to the amine branch if it's not a suffix? If it's not, amine becomes amino. So you're going to start calling this NH2 thing amino. Okay, because you're not naming the molecule after this. It would be amino and it would have a position 2. So it's going to be 2 amino. Prop 2 E in 1 all. Okay, is this clear?
Clear.
Chalo, so I said let's do another one. What would happen if you have a molecule in which there's a carboxylic acid and let's say there's an aldehyde as well? Okay, what's going to happen? Would you call it an aldehyde? Would you call it a carboxylic acid? And how would you name it? And let's add a OH as well. Okay, this would have 1H, this would have 2H, right? So again, the chain is not very complicated. It's a straight chain, so it's 4 carbon atoms, right? So that's your main chain. It's going to be butanoic acid, right? Since carboxylic acid is the highest precedence group. So over here, at the top, you have the COH group, and aldehydes are less important compared to carboxylic acid. So hence the molecule would be called butanoic acid. There is no double bond, so AN would remain AN and it would be butanoic acid. This side would be position number 1. Now I told you one more thing, and that was that the OH obviously becomes a branch, okay, because the molecule is not being named after it. So this one is your hydroxy branch, and the position of this hydroxy is 3, okay, because it's I mean the carboxylic acid is at position number 1, so it's 3 hydroxy. But now the issue is what happens to this aldehyde? How do you incorporate aldehyde into this? Because I told you that an aldehyde or a nitrile, they always maintain suffixes. So what happens to an aldehyde? What's the suffix of an aldehyde? It's Al, right? So what you do is that before oic acid, Al is also added. That it's an aldehyde. And if this is number 1, the aldehyde would be at position number 4. So it's going to be 3 hydroxy, uh, butanol, and then oic acid. Okay, so remember, a molecule can have multiple suffixes. It could be a I mean, its name could end with oic acid. It could also end with Al at the same time. Okay, brother, is this clear? Minail, clear?
Yes.
Yes.
Okay, everyone else, is this clear? Abba, is this clear, Rida?
Yes.
Acha, so it's not as complicated as it looks, TK. If you know the precedence, TK. I mean, the rules are really really complicated, TK. I'm not even teaching you 10% of the rules. You can't really go into that much detail because it's kind of impossible. Uh, but the thing is, just remember about these 6 functional groups that carboxylic acid, nitriles, aldehydes, and ketones, they would always remain a suffix, even if they're not uh, even if they're not the most important functional group. You're going to add them at the end. Okay, always at the end. OH and NH2, they get converted into branches, and you add the branches alphabetically in front of them. Numbering is always done to give the smaller number to the most important group. Okay, so this is how you name molecules, and that's pretty much it. So so let's try and practice a few more.
Sir, a question. What if we had a ketone instead of aldehyde? Will we just add O and E instead of Al?
नहीं कर लेते हैं. We will do one. Okay, let's say अच्छा, I have this molecule, ठीक है? अच्छा, and there's a branch even CH2 CH3, ठीक है? And this one is CH3. This one is going to have 1H. अच्छा, so I have this molecule. The longest chain should have the maximum number of groups. So this is the longest chain, right? Not the other one, okay? That the other part would not be included. Now this one, your main chain is an aldehyde as well as a ketone. It has 4 carbon atoms, so it's going to be called bute, and it's saturated, so that's An. Now, would you call it an aldehyde or would you call it a ketone? Which one is more important? Okay, so that would be based on aldehydes are more important. Okay, if you can see over here, ketones are less important, but both of them would always remain a suffix in the main chain. So aldehydes would be right at the end, and there's going to be O N E. I mean, the numbering would be done because aldehyde is more important. So all the numbering would be done to give a smaller number to the aldehyde group. Okay, so the aldehyde group would be at 1. You don't have to write 1, but even if you write it 1, it's fine. The ketone would then be at position number 3. So that would be 3 on and 1 al. And this would be your branch. The branch is 2 carbon atoms, so that's eth and yl. And the position is position number 2. Okay, all the counting is being done from this side. Okay, clear? Bhaskar, is this clear?
Here, sir.
Achha, so just I'm going to give you questions, ठीक है? Just to randomly, ठीक है? Try doing this exercise. So the question is, to try naming this molecule. So this one would have one H, Cl, another Cl, three H's. ठीक है, this one as well. I'll also do one example, just one example very quickly. Like if you have the same branch repeating over and over again. I mean, what I'm saying is like if you have a carboxylic acid with multiple OH groups, right? If you have carboxylic acid with multiple OH groups like the one that you see in the screen, how would you name this? It's going to be 4 carbon atoms in a row. Okay, that's your longest chain. The main most important functional group is a carboxylic acid, so it's going to be called butanoic acid. It is saturated, so AN remains, and it's going to be called butanoic acid. The rest are your branches, the OH. Now there are two OH branches. One is at position 2, the other one is at position 3. All your counting would be done to give smaller number to the most important group. So you can either write 2-hydroxy. So this would be called hydroxy. So you can either write 2-hydroxy, 3-hydroxy, or you can put them together and you can call them 2,3-dihydroxy. That can be written as well. So if you have the same type of branches that are repeating over and over again, like if you have multiple methyl branches, you can call them dimethyl if they're two branches of the same type, or you can call them trimethyl, and you can give the numbering to each one of them. Okay? Is this clear?
Clear.
Chalo, theek hai. Try naming. So try naming. I'm going to post this on the WhatsApp group as well. Try naming these two molecules. Okay, so you're going to get very simple questions on questions like these. Okay, the ones that I'm showing you on the screen. Chale, koi question? You can ask the question. Otherwise, you can try working on the answers to these questions I'm posting on the group. Chale, okay then. Take care.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz.